Okay, class, let's go over this quiz, the mastery quiz here. Question number 1. On Earth, a cannon is fired horizontally with a speed of 28 meters per second from the top of the cliff. And the cannonball lands 100 meters from the base of the cliff. Okay, so sorry, I didn't change it here. This is 28 on yours would actually have the right numbers here. And this is 100. Okay, so it's kind of showing you visually that it lands horizontally 100 meters from the base. So that is the horizontal distance. And it's launched initially at 28 meters per second, horizontally. Okay. We don't have much else, but we do have some other things there that we know about. It says that it's fired horizontally. That means it's not fired vertically, and there is no speed in the vertical direction since it's fired horizontally. It's not going up or down when it's launched. So that means in the vertical direction, its initial speed is 0. And gravity is 9.8, and that's down. We don't have any other information now except to now solve this with physics. Horizontal direction, we can use this velocity is distance over time, the constant velocity one. Rearranging for time, we get that is distance over velocity, and the distance is 100 in this column over 28. Pull up Mr. Calculator. And we get 100 divided by 28, and it took 3.57 seconds to get there. 3.571 seconds to get there. So I'm going to change it to black now because these are the things that I calculated. 3.571. And the time is 3.571. Now we have three things in the vertical direction. This will allow us to calculate the other two values. What is the final vertical velocity? That is this. It's asking for that value. So vertically, that was A. And B, we have three givens. VI is 0, A is 9.8, and the time is 3.571. We're asking for what is the final velocity. Final velocity will be calculated from this formula. And the initial speed is 0 plus 9.8 times 3.571. So the number that's on our calculator, multiply that by 9.8, and we get 35. So the final velocity here is 35 meters per second. Okay? And that's the answer for B. Now we're working on C. How high is the cliff? Well, you can use whatever numbers you want. Basically, I'm just going to color code this. How high is the cliff is asking for the vertical height of the cliff, how far it falls down. So you can go ahead and use the time. If you didn't want to use the time, well, you have to use the time, but if you didn't want to use the final velocity, you didn't have to. So I'm just going to go D equals VIT plus 1/2 AT squared, one of my favorite kinematic formulas. Why? Because when VI is 0, it becomes very simple. That term is gone because VI is 0. So the distance is going to equal 1/2 9.8 times that time, 3.571 squared. So I take 0.5 times 9.8 times that time up there, that number squared. And I get 62.50. So D is equal to 62.50 meters. And that's the answer for C. Okay, that question is done. Best yet, now just copy those answers down. A, B, and C down below. So we could zoom out there and write those numbers down. 3.571 seconds. B is a velocity of 35 meters per second down. And C is a downward distance of 62.5 meters. Okay, let's zoom back in and do question number 2. Not everyone got this one correctly, especially that last part of that question. On Earth, a cannon is fired horizontally with a speed of 35 meters per second. Again, horizontal, I'm just going to fill it in right now. This is 35 meters per second. And it's from the top of a 60-meter high cliff. So that is a vertical 60 meters. So the question here, sorry I didn't update the pictures here. This is 60 meters high. Okay, what other pieces of information? Well, it's fired horizontally. So because of this word horizontally, we can fill in this vertical. That vertical is 0. And we know gravity is down as well. So how long is the time in the air for? Okay, we can use the quadratic here to solve for time. D equals VIT plus 1/2 AT squared. And because VI is 0, that term goes away. And then solving for time, we get T is equal to the square root of 2D over A. So the square root of 2 times 60 divided by 9.8. So we take the square root of 2 times 60 divided by 9.8. And that answer is going to be about 3.5, 3.499. I'll just write down 3.5. And that is the answer for D. I'll change to black. Here we go. How far from the base is E? So basically, we're trying to find out how far from the base of the cliff is this one, the horizontal, that distance there. And we can calculate that by, well, we just got a time of 3.5 seconds. So this, how far from the base is going to be, in the horizontal, we only have one formula. D is velocity times time is the arrangement of that one. Velocity is distance over time, constant velocity formula. Velocity is 35 times the time of 3.5. So we multiply this by 35, and we get an answer of 122.47. How about 122.5 meters? And that is how to solve for E. And F, what is the final vertical velocity? Well, vertically, I'll go back to red. That's F. Some people want me to start with that one first, but we can go VF squared equals VI squared plus 2AD. And VI is 0. So VF is just going to equal the square root of 2AD, which is going to equal 2 times 9.8 times a distance of 60. And that's just one. Okay, so let's pull up the calculator here. So we go square root of 2 times 9.8 times 60. And we get a vertical velocity of 34.29 meters per second, and that will be down. 34.29 meters per second down. Thank you. Nice fanfare, music celebration that I almost got my full way of this question. Let's do the hardest question, is just what the final velocity is. And it's only hard because we haven't done too many of them. It is pretty darn easy. When we're asked for the final velocity, and velocity is a vector. We know it's going horizontally at 35. We know it lands at 34. And this question is 34.29 down. And what it's asking you for is this vector. And that requires an angle as well. So Pythagoras to get the hypotenuse, and inverse tan to get the angle. So the vector velocity is calculated from the square root of 35 squared plus 34.29 squared. That's the A and B all square rooted. So let's get that value. It's not going to be that hard. So the square root of this number squared plus 35 squared, all square rooted, we get, it looks exactly 49. 49 meters per second, and now I need an angle. Okay, so I need to calculate this angle, and to get that angle, we have to do the inverse tan, because we have the opposite and the adjacent. Inverse tan, we'll do 34.29, the opposite over the adjacent 35. That's going to be very close to 45 degrees because it's almost an isosceles triangle. So inverse tan of 34.2928 was the number, divided by 35, and that's going to be 44.4. So 44.4 degrees. So to write out the answer, we write down 44.4 degrees, and we put BTH for below the horizontal, because it is below the horizontal, not above it. So let's just highlight that answer. And the last 5 seconds of the quiz, we put down 49 meters per second and the bracket of 44.4 degrees BTH. What I'm looking for on this mastery is just have the numbers in here at the bottom, and that's what I check. That's how you do the mastery of this horizontally launched projectiles.